So good evening, everyone. How are you today? Okay? Still interested in no more machine learning stuff? So good. So my name is Jo-fai, but people call me Joe because it's easier to remember. So I work for H2O, so I'm a data scientist, but I have an unofficial title for my work because I travel a lot, so they call me traveling data scientist because I just travel everywhere to do this. So this is like my 30th time to talk about the same thing and with Kuba. But hopefully I will just give you like a feeling of what H2O is. So what do we do, what kind of tools do we have, what can you do after this workshop or after this meetup. So I only got 45 minutes today, so won't be enough to go into all the details, but hopefully I'll give you all the links, all the materials, all the things that you need after this meetup to try H2O. So first of all, everything that you can, all the slides, or the code, or the data, you can download it from this link. So you don't have to worry about it right now. So I'll post everything to the Meetup page afterwards. But everything will be online. So first of all, this is a agenda for today, not only for my talk. So we have two talks today. First of all, I want to introduce H2O to you. So our platform, H2O, also called H2O, and doing some demos if we have time. And then we'll move on to a different project called Deepwater. So it's about our integration with TensorFlow, MXNet and Caffe with H2O platform. So then we have a short break. Then Kuba will come here and talk about H2O and Spark together, so that we call it sparkling water. And of course, this is more interactive section than other meetup. So if you have any questions at any time, just raise your hands and ask me questions, okay? So just quickly, something about myself. So I wasn't trained as a computer scientist. I was trained as a civil engineer. But then I discovered H2O about 3 years ago, and I learned about H2O and other machine learning stuff from that point, and then somehow become data scientist. And somehow I joined H2O as well. So this is my GitHub repository. So you can see that I'm not really a Python guy, but I'm more like a R person. So all my favorite repository are written in R. Or maybe you can't really see it from the screen. Is there any way we can do it? Oh, there's not much we can do, but let's move on. So this is what I really like to do with programming language. So I don't want to do machine learning when I start learning R. I used some fun projects to help myself to learn programming. So this is one of the packages I wrote a long time ago. So we can extract the colors from any image. So just supply image, and we extract the main colors from that image. And then I went on to, hi. Yep, so this is only a k-means algorithm. So I use k-means to extract, because the image itself is RGB, so red, green, and blue. So using that as point, or like numerical value, and use k-means to find the key cluster of that color space, and use that to transform it into domain colors. That's why I did it. That's simple k-means algorithm.
So this is the end result of the job, or you use the colors to try to classify specific figures?
Okay, so the input is the image. So you supply an image. The output is the colors. Color is like the code in R, so it could be the hex code in R. So all I need to do is just to supply that image, tell this program how many colors I want to extract. So maybe 3, 5, 4, and then that will just extract the main color using k-means, like a k-mean cluster. Okay, and then I move on to do more stuff. So I create this data visualizations about the crimes in UK, and that led me to a conference in UCLA. So it is 2014, 3 years ago, when I first met the H2O team there. So the first impression of H2O is that, oh, someone was crazy enough to use H2O as the name of the company. So they could be either crazy or smart. So that's why I gave it a try. And after that, I just really love it. And then I move on to use H2O and other stuff. Yes, again? Oh, this is for marketing. It's really because previously it was called hex data, so 0x data. So some people, they don't know about computer science. They may not know what is it about. So they changed the name from OX hex data to H2O, and it's easier to explain from that point. Okay, so And so I use H2O and then another platform called Domino, and to do something about machine learning. So I went on to join a Kaggle competitions, and I wrote a blog about it. So that's how I get into machine learning and H2O. Okay, that's all about me. Let's move on to H2O. So sometimes I call it H2O, sometimes I call it H2O.ai. So H2O.ai is the name of the company. It's also the web address, so you can just type it onto your browser. So we are a small company, small and young company based in Silicon Valley. So most of the people, they're based in California or New York. So I am based in UK, Kuba is based in Prague, Carl is based in Prague as well. So we try to expand it in Europe as well. So if you're interested in joining H2O, please speak to Kuba afterwards. So we mainly have a few open source products. So the first one we talk about today is the H2O open source machine learning platform. Kuba will talk about sparkling water, which is our integrated with Spark. And I will talk about deep water, which is the GPU deep learning integrations. And Steam could be something that I can do it in the future. So these are some of the faces. As you can see, there's me there and Kuba there. And we're lucky to have 3 professors from Stanford. So to me, they're legends, the legendary professor from Stanford, to guide us through a journey, because we implement our algorithms from scratch. So we need someone experienced like them to help us through the journey. So this is how they work together. Like recently, we tried to implement one of the algorithm on GPU. So that's why they come together to our office and work together with our CTO, Arno, in the middle. And that's how we work together. The professors? No, they just give us advice. So because when we try to implement the algorithm from scratch, you need someone to double check that everything is accurate. And because we want to make it fast and powerful, so sometimes maybe we have some really clever implementations that we need someone really understand the logic behind everything to be there and look at all the things for us. Because it's hard for us to just put out something out there and let's try it without some professors to check it through beforehand. So it's really, really useful and valuable for them to just sit there and look at it before we just push it out. Okay, so we have some open source product. But this Meetup, we only focus on 3 of them. So the H2O platform, deep water, and sparkling water. A bit more about the company. So some people ask, you guys are open source, so how do you guys make money? So the way that we make money is we like consultants. So people can try H2O for free because it's open source. But some companies, some organizations, they may not have enough expertise or experience in implementing H2O for large-scale product. So they may come to us and say, H2O, can you help us to implement this with our company? And that's how we make our money from the customers. And the cool thing about this model is that when we work with the customers, we fix some bugs and we make some improvement in the H2O. And we put everything back, the good stuff, back to the open source versions. So all the users, all the customers, they will benefit from every work that we work with customers. And this is one of the charts that they frequently use in Silicon Valley. So this is called the data science and magic quadrant. So everyone here, they try to swim to the top right corner to be the leader. So we see that H2O is the first appearance here. Right next to it, we got Data EQ and Domino Data Lab, which I worked before, and Microsoft there. We try to swim up to IBM, SaaS stuff. Okay. But the only thing that really stands out for H2O here is that H2O is the only open source guy in here, the only good guy in here. But everyone else, they're all closed source. But some of them, they already have H2O implemented with their platform. So for example, Domino and Data EQ, they have H2O in that. Because we have the Apache 2 version license, so people can just use H2O in their product without open sourcing their own code. So if you want to check out more customer stories, so just go to our website and you can see customer section, and there are lots of videos of different customers, and then they can see that you can see how they use H2O for different kind of business to transform their business. Okay, so of course, the other thing that I'm doing quite a lot since I joined H2O is that I travel a lot to different cities to spread the word. So this is usually the time that I need to do a selfie. So if you don't mind, we can just take one together. Right, 3, 2, 1. Okay. So usually this is job done, then I can go home. Okay. But let's move on. So I'll talk about the company. So first of all, before I introduce the actual platform to you, I want to give you some reason why you may want to try H2O after this meetup. So I'm going to use Cedar Parker. So he is a data scientist in LA. So he did some really good work on benchmarking different algorithm, different implementation of the same algorithm, using R, using Spark, using Python, using H2O, using XGBoost. So one of the findings that he got in that website is that H2O is really good with big data. So this graph here, you may not see it very clearly, but on the x-axis here is the size of data. So from a small data set here, like be 10,000 to 10 million here. He found that H2O is the fastest when you move on to big data. And if you compare the AUC, the area under curve here, so this is the accuracy, AUC here, one of the metrics to measure the performance, is almost the same with other algorithms. So we didn't sacrifice the performance, the AUC, for the speed. So this could be one of the reasons why that you want to try H2O, because it's just faster than other algorithms. Some people like to use H2O for cargo. So how many of you have heard about cargo? Oh, cool. So cargo is a data mining competition, so it's really hard to win. So people like to use H2O as part of the mix of algorithm to create something really accurate, and that's quite cool. And also people like to use H2O for research. So in academia, they actually wrote some papers with H2O as a machine learning engine. So these are some reasons that you may want to try H2O after this. Okay, now, so this is the time to just finally give you the feeling of what H2O is. So first of all, I have to borrow some the answer from my colleague. So Raymond, he's the director of product engineering at H2O. So someone asked, what does H2O, or formerly Hawks Data, do? So his answer is very cool because it summarizes everything we do with H2O. So we are like a high-performance in-memory machine learning platform that you can use multiple APIs. So if you can use Java, you can use the pure Java API, or you can use R, Python, the REST API, or we have the web interface as well. And we have a collection of different algorithms that you can use, and we have a world-class accuracy as well. So let's go through like the high-level architecture of H2O. So I will go through it one by one from left to right. So first of all, it's a machine learning platform. So first of all, you need some ways to connect to your data. So we have different support on, say, from a local CSV file or Excel file, or any fact files in that. You can use it to try H2O. And then when you feel comfortable with H2O, you can try much bigger. So you can use your database. You can use Hadoop, Spark to connect to H2O and then do machine learning after that. Then in the middle here is the heart of H2O. So this is all the compute engine of H2O written in Java. Everything that you use in H2O, in this version of H2O, H2O 3, is written in Java. Because we want to use Java for high performance and scalable performance for this platform. So you can expect you can do all the typical tasks. You can load in the data, you can do some munging, you can explore it, you can predict, you can train the model. So even supervised or unsupervised model, you can get the model, make some predictions, and you can export the model as well. So this is a typical machine learning engine, but this is all written in Java. So this is an overview of some of the algorithms that we have in H2O. So on the left-hand side, we have the supervised learning algorithm. So GLM, naive Bayes, random forest, GBM, the gradient boosting machines, and deep learning. So some of the really typical machine learning algorithms that you can find in other platforms. But this one are all implemented by H2O, and they're implemented from scratch. And we aim for really high performance and scalable performance for all the algorithms in here. So similarly, we have unsupervised learning here on this side. So k-means here, PCA, the principal component analysis, and other stuff for unsupervised learning. So we have covered most of the things that you need for doing machine learning tasks. Yes? Yep. Yep. So we can call this deep learning here, the classic H2O deep learning is a fully connected, the multi-layer perception model. So it's not the new convolutional net you can find in another package, but this is the one that is very suitable for business kind of data, like tabular data. So this is the one that we use in H2O just to get the more people to use H2O first. But now, because we found that we need to move on to capture more kind of problems in deep learning. So that's why we have the deep water project that I will discuss later on. But that's a good question. Okay, so just a bit more on how we distribute it. So you can use it. Oh, sorry, please. Okay, so we have the basic, like a variable importance. So when you train the model, so for GBM, for random forest, for deep learning, you can get the variable importance from different features. So from that table, which I will show in a demo later on, you can decide whether you want to like omit or exclude some of the features to make it faster for training. And that's what we have in H2O. Oh, yeah, yeah. So most of it is automatic. So H2O will look at the data set. So if it looks like a date, then we'll change it to the date. If it's a string, then we'll change it to like a elem, which is the categorical value in Java. But there are points that is like a number, like integer in a column, but it's actually like a class. You can change in H2O to change it into categorical value. And if there's something like missing data, or you want to do one hot encoding, it will be done automatically behind the scenes. So user doesn't have to specify any command for H2O to do that. It will just do it for you automatically. Is that okay? Yeah. You can ask more questions. Yeah. Okay, I think for now that's the most basic one. So one hot is the more missing value is the basic one. For the next generation of H2O, there will be more feature engineering stuff, but not in this version. But let me just go through this version first, okay? Okay. So this is one example that we use 10 machine here. So the graph on the right-hand side here is showing the CPU usage of 10 different machines, so 10 nodes. So what we have here is that we want to use H2O on 10 different machines to train on a deep learning model. On one of the data set here is about 160 million. So it's not really big, but bigger than a lot can handle. So we managed to train it within 1 minute. We can get to a reasonable answer with all this CPU power in there. So that's what you could do after this Meetup. So you can start with your own laptop, desktop. So when you're happy with H2O, you can connect to more cluster and use more power to make it quicker for the training. Okay. This version is CPU based. You know that, right? This is CPU based. So this is H2O 3, version 3, and it's all CPU based. But the deep water section that I will talk about later is all GPU based. So there's like an overlap in that. So let's get back. So this algorithm that you see here, they're all CPU based. Okay? Okay. So how many people would like to use Java in here? How many people use Java? Yeah. So you got the answer. So we don't really like to use Java. We use Python or we use R to do data science stuff. And that's why we have different API for different people. So we try to make most people happy. We have R, we have Python that makes like 90% people happy. And if you don't want to use any programming language at all, we also have like a notebook style, so a web interface to use H2O, which I will show you in a bit. So first of all, if you're like an R user, that this is like a simple R code for you. So this is H2O package in R that you can train random forest, GPM, and deep learning model here. So the basic syntax is quite similar to other algorithm in R. So you supply X, which is the features or predictors, Y is the target or label or response, and then you point to the data frame, which is in H2O data frame, which is in Java, and that's it. That's the minimal API that you need to train a model in different algorithm. But this or that when you execute this command here, it's just using R to talk to H2O, the cluster H2O, and then we will use the Java to do the training. So it's not using R to do the computation, it's using R to just do the interface to communicate with H2O. But because there are a lot more packages in R, so that's one of the demo that I did with IBM earlier. So we can we can use H2O as part of your ecosystem. So I use H2O to, in this case, I trained a PCA, a principal component analysis model, and use the result with other package in R to visualize it and make it into a Shiny app, which I will show it later on. So that's a mix and match with other things that you can do with H2O. Sorry? This is a small data set, so it doesn't really count, but it depends on how much CPU power you have. So for like bigger data, if you have more cluster and more powerful machine, they'll be fast because it's all parallelized in the background. Okay, so if people like to use Python, sorry, let's go back one slide. If people like to use Python, this is the interface or the API for Python. So similarly, you don't see anything about Java. It's most native to Python. So again, you specify X, the features, the target, and then the data frame, and then you can use the doctrain command in Python, just like scikit-learn, to train the model. So again, this is using Python as an interface to talk to H2O. So when you execute this command, the computation is done in Java. Okay, so finally we have like the most user-friendly interface for H2O, which is our H2O Flow. So this is like the web interface for anyone without programming language experience. So you can show it to your friends or colleagues who don't know how to code, but they can still use H2O with just the web interface. So they can import a data set in there and then select which model they want to train, either deep learning, random forest, GPM, etc. And then they can export the result as well. Okay, so usually people stop right there when they have the model. They can just use it in our Python. But some people like to do it use it actually in productions. So they can export the model into a single Java object. So they can stick it into a different environment. So at that point, they can just forget about H2O and just use that Java to make prediction. We call it scoring, just make prediction in a different machines. So that's how we can do it. So from data, if I go back here. So from different connector to data, to compute engine in the middle, and to export it as a single Java object. So this is the machine learning platform H2O. And it is open source and free to use. Okay. Yep. Yes?
So the question is, you're providing KPI and for a user as in the program, it looks like some sort of platforms. So my question is how customizable it is. Is it in case I need to make some modification, I want custom loss function, or I want to try to do some modification into a phrase which is not in the box.
Okay.
So how can I do this?
Can you repeat the question? I didn't hear.
So I think that is how to use custom metrics for evaluation, right? So we.
What's the means of customization? To which extent I can customize the algorithms themselves?
Yeah. So everything H2O free is on GitHub repository. So you can fork it, and then you can make your changes in Java. So if you know Java, you can change the code yourself. And after that, you can build H2O, like your special version of H2O. So that will include all your custom metric, custom evaluation, custom functions. So some of our customers do that. So they have their own algorithm. So, but they don't want to add people to use it. So they have their own H2O version. They can build it from scratch using the code. So everyone can do it if they know Java. Okay?
And then I will have to merge to get new updates for the H2O. I have to keep in line with
It depends on how frequently you want to update. So if you take a snapshot for today, take it for now, and then you make your changes, should be all right for a long time. Only if you want to get the latest features of H2O from the master branch, then you can pull it and then build it again. But the building process is not really long, so it's just a few minutes to build it. Okay. Yeah. So that's a good question to lead to this page here. So you may not see all the details from this page, but this is the document page of H2O. So, yeah. Is there any questions? Oh yeah, yeah. So I think he is comparing the GBM here. So he's comparing the gradient boosting machine implementation in R, in Python, XGBoost, and so it's not exactly like an apple-to-apple comparison. So some people like XGBoost, it's fast in some case, but then when you move on to bigger dataset, H2O got the advantage. But because of the implementation is slightly different, so they're not exactly the same. So for example, if you supply the same parameters for XGBoost and use exactly the same, like really the same parameters in GBM, the result will be different. So it's hard to compare apple to apple, but they're quite similar anyway. And the good thing is that we have XGBoost in H2O now, which I will show you in a bit. So we have both. You can use both. Yeah. Yeah, you can use it on a GPU as well. Okay, let's go quickly here. Okay, so that's the address I want you to remember. So it's documents, so docs.h2o.ai. Then you can find out more information about H2O. So I may not have enough time right now to show you all the demo, but I will skip that for towards the end of the talk. But let me just go to the deep water first, okay? So I also want to point to this page here because I'm going to give a H2O tutorial at the PyData conference on June 30th. So this is like a more full-on hands-on workshop on using H2O with Python to do with some basic data science workflow. So if you're attending that conference, please go there. If not, there's a link somewhere here that you can just download all the materials and then on a notebook that you can work it on yourself. So it's very self-explanatory, so it's all Jupyter notebook in there. You can just look at the results, look at the explanations, how I do every step. So the main point of that tutorial is to optimize some of the algorithm in H2O. So GBM in this case, for one single simple toy problem. So we were trying to minimize the error of predictions for that data set, and that's so different step from the GBM default values to more manual setting to cross validation, error stuffing, and all different tricks to make it better. So that is the link to everything. Right, so let me just move on to deep water. So sorry about the time, so I have to rush through all this, but you can have more time to ask me after the talk. So this is the deep water project that we have at H2O. The main reason that we want to do this is because you have some limitations of the deep learning in H2O. So as I mentioned about before, H2O deep learning is a classic CPU-based deep learning algorithm. So it doesn't really scale well when we have like image or text or a data set for deep learning problems. So we need some other implementation of deep learning in H2O to make it more usable. So before I start, so how many of you have heard of TensorFlow? Yeah, MXNet and Caffe? Yeah, cool. Yeah. So they are all like really good open source deep learning tools. So I'll just quickly go through them before I show you a demo. So TensorFlow from Google, is getting the momentum here. So they're putting more and more resource and effort into TensorFlow. So we think that in the long term, the user of H2O can benefit from all the new features and all the new functionalities in TensorFlow. That's why we want to have TensorFlow with H2O. And similarly, we think that MXNet here, so although it's not as popular as TensorFlow, but it still have a really good long-term future because they have the backing of Amazon. So we want to have the new features in MXNet in the future, so actual users can benefit from that as well. And lastly, we have Caffe. So I think it's more popular in the academia. The one cool thing about Caffe is the model tool that you can just download the model, the training model from others people. So people with really cool GPU hardware, they can train on larger data set, and they have a really good model that they can put it on model tool. And someone though like me, I don't have a really cool GPU cluster at home. I can just go and grab the model and just use the model. And that's one cool thing that we want for H2O in the future. Yes, question?
I'm not sure if you can talk about it, but you just tell us if there are any efforts for that.
I think we don't have a lot of support of Caffe 2 yet, but we're still working on Caffe one. But I think we are working on, so the guy working on Caffe is getting all the new features from Caffe 1 and 2 together and put in H2O. But I think we are not getting to the point that we can release a really useful one for Caffe yet. But we're working on it. Okay, so also we have our H2O deep learning. So at some point last year, I think in September, there was a survey about the deep learning tools that people use for their work. So at that point in time, H2O was just as popular as TensorFlow. But of course, TensorFlow just went up after that. So we knew that there are some tools that we can use in the open source territory. So TensorFlow, MXNet, Caffe, and H2O deep learning. So we want to bring them all together to make it easier to use. So we want to use the H2O platform, which is quite user-friendly for most people. We want to use the same platform to unify all these two together in one single box. So that means that for the user of H2O, they don't have to learn a lot of the syntax. They don't need to learn about the input or output requirements for different tools. They just need to learn how to use H2O. So once they have managed to use H2O, they can use TensorFlow, MXNet, and Caffe. Like there's a new algorithm in that. No, we don't offer the pre-trained model, but the pre-trained model is there. Oh, we want to offer the ability to upload or to load the pre-trained model in H2O. So you don't have to train it from scratch. No, that's what we offer. So we don't have enough resource to train every model, right? Yeah, sure. I think you get it, yeah. So that means that now with this kind of different backends, so TensorFlow, MXNet, and Caffe, so suddenly actually become more powerful in deep learning sense. So we can tackle different problems like a text, video, image, and other kind of problems that we couldn't do with the classic H2O deep learning. And if you want to download it and we want to try it, so it's not a stable version 1.0 yet, but it's likely built. But you can download it from our website here. If you go to h2o.ai and then /download, then you can see it on the second column here on your screen. There's a column for downloading the H2O GPU version in here. So you can have the pure Java, or the Python view, or the R package, or just the Docker image as well. So you can try it after this workshop. So one of the things I want to point out about the benefit of using deep water. So imagine if you're already an expert user in TensorFlow or MXNet Caffe, you don't really need to use deep water to do the same thing. But this deep water is more for the beginners, for people who don't have enough time to learn everything from scratch again. They just want something really quick to do it in H2O. So we want to help them to make this task quite easy for them to utilize some of the different architecture of the neural network. So this is like some of the classic neural network structure from different papers from Lilat like long time ago to the recent one ResNet. So we want to give the user the options just to choose from H2O, and they will have the structure in the H2O when they train the model, and they don't have to configure everything from scratch. So for example, this is like using H2O deep water with the H2O flow. So user can have the option here. You can see that the drop-down is here, go network. They can choose from Lilat, ResNet, everything, VGG, AlexNet, like the thing that you see in here. They can just choose it from the drop-down list. So once they have done that, they will have the structure in place for them to train the model. So equally, we want to make it easier for user to switch from one tool to the other. Just 1 minute. So we want to have the backend option here, so you can change from MXNet or TensorFlow or Caffe just by clicking one, selecting a different option in there. So what's the question?
So with the zero components for computer vision, are there also other networks that are more fancy, like RNNs or network?
So I think the list can go like for forever, right? So we cover most of the most famous or most common ones here, right, first. So we always start with the that because it's like the small one, easy to train, to get a feel. So people can also build their own, so they can use MXNet or TensorFlow to build their own structure. So it's not only restrict to the list in here, so people can also build their own, which I will show in a minute. Let's go to here. So that is how to use H2O deep water with the H2O flow. But if you want to use a programming language like R, this is how you would do it with R. So you have the same kind of interface, H2O deep water here. You point to X, Y, and the data frame. You supply other parameters here. The most important two things are the backend and the network. So you can choose MXNet or TensorFlow right here, or you can choose different network in here in the net, for example. And that's the two options that you can just switch quickly to other things, to try different things, to experience with different kind of structure, like quite quickly. And the same thing is for Python. So this is the API in Python. So again, you can see the backend there, backend, and the network option there. That's the page that you can change to different structure and different tools quite quickly. Okay. Yep.
Since you're using different networks actually spit out your training protocols a little bit differently. For inferencing, you then have to use these individual networks to actually inference, correct? Or you have actually some inferencing models that does some you're talking about every training.
Yep. I think for starters, so we focus on supervised learning. So we focus on a simple problem first. So this is all about, you have the answer, you have the labels. For example, image data set, you have label. Sorry?
It's now training. You gotta run it after training.
Oh, okay. So after the model, after the model, you can export the model in the native H2O format, and then can use it for predictions. So what we try to do in here is to unify the process. So for example, if you train the model in MXNet, just the pure MXNet, and then you train the same thing in pure TensorFlow, you have two kind of different output requirements. We try to make it into one single requirement, so one single workflow to have different tools. So you can, let me just go to this page here. So I just fast forward to one example that I want to show in later on. This is just showing that I want to do a simple toy example to train a linear net on a data set with MXNet and TensorFlow. The main thing that I want to show here is that you only need to switch one argument in that. And then after that, the model is in native H2O format. So it's not in the native MXNet or native TensorFlow, it's a native H2O format. And that, you can use it to predict the new image, and then you can use it to store it for later use. So that's what the thing that we did to simplify the workflow, to make it easier for people to have like different, they want to try different algorithms at the same time, but they don't want to have to learn MXNet and TensorFlow from scratch. Yep. Okay. So I apologize, I have to go really quickly because I don't have enough time. But if you want to go through more examples, this is the link that you will get when you get the PDF. Then you can go through more deep water examples. So we have regressions, classification, other things that you can do with deep water. So you can see all this notebook on the GitHub repository. I just want to go through a really simple use case. So this is a really toy example use case to classify like the image of dog and cat and mouse using deep water. The main purpose is just show you the API of deep water, right? So these are the input in here. You can see there's a raw image of cat, of mouse and dog. So what you need to do with deep water is to specify a reference table. So here is a CSV file that I create with the actual path, the relative path of the image on the left-hand side, the first column. And then the second column here is the actual label. So that is the only thing that you need to tell H2O deep water where you can get the image from. Okay? So let's go for the basic usage. So in H2O deep water in R, so you just import the text file that I showed you before. So it's just the reference here, so all the image in here, and then the label in here, just to tell H2O where to get the image when it's ready for training. So then I go back to the slide that I showed before. This is how you can train a simple lineage model of that data set using the API. So if you want to train the MXNet model, this is the top half here. You can see that the syntax is quite clean and easy to understand. So you don't have to learn about the actual syntax of MXNet or the actual syntax of TensorFlow. It's just a similar way that is like other H2O model in R or Python. So it's apply X, the path of the image. Y is the response, which is the label, other cat or dog or mouse, other arguments in there, and then you specify the backend, the network, and that's it. So what you get after this is the model in a native H2O format. So it's trained on GPU if you specify using GPU. And this is the output when you print out the model. So it's not like the MXNet or TensorFlow model. It's the native H2O model. So we can see this is like the summary of the model. So some of the information of the model, some of the metrics here, the confusion matrix in here. There's some information about that the first model. But sometimes that default value is not good enough. So you may want to use your custom network. So for example, if you know how to use MXNet, for example here, this is the syntax of MXNet. So all you need to do is to create a function to turn this kind of structure into one single file. So this is the file here. So you save that into a JSON file here. So with that physical file on the hard drive, then you can ask H2O to look at that JSON file. So at this point here, H2O will look at this JSON file here, and then H2O will understand that you want to train this structure for the neural network. Okay. And that's how we do it in deep water. So you point again, same the path, the label, the data frame, and then other arguments. The different thing is the network definition file here. So you actually point it to the file. Yes, there's a question there. Yeah, we're working on that. Yeah, we're working on that. Not yet. But because we have Caffe and TensorFlow and MXNet, so there are many other models online that's be trained model online. So we want to do that as well. So, but we're working on that. So it's work in progress. So by the time that maybe next time I come here, then I can show you an example that you can use, just download something from the internet and use it. That would be quite cool. Okay. So this is just showing that if you use the custom network model, then you can just still print out a native H2O model. Okay. So quickly go to conclusion. So this is our project Deep Water. So we want to bring H2O with TensorFlow, MXNet, Caffe all together in like a big party. We also want to give the user all the goodies from the classic H2O platform. So you can have the user-friendliness platform of H2O. You can use H2O web browser interface. You can use R. You can use Python. There's the same interface that you use the classic H2O. Just want to unify the process, so people don't have to learn from scratch all the MXNet or TensorFlow, all the things that you need. You don't have to install them. You just need to download the jar from the download page, and then you have everything in one single jar, package in one single jar. And because it's all open source, so maybe in the future that party will go bigger. So we already have XGBoost in that file, so you can use XGBoost in that jar as well. So please go and download and try it. And so just quickly about other things that are happening with H2O. So not just the deep water, so we have other things happening as well. So I don't have enough time to go for the details, so this is a slide that you can just click on the links to see more details of different projects. So, but most notably is this GeoAI thing. So GeoAI is our new project to work with NVIDIA, MAPD, and Anaconda. So we want to move the whole machine learning platform to GPU memory. So we don't want to copy and paste GPU memory to CPU memory back and forth. We want to do everything on GPU. So that is the new thing that we have, and it's open source as well. So please check them out. Okay. So I may have some time for demo later on after the second talk, but for now, this is from me. So thank you again for the sponsor and organizers. If you want to contact me, this is my contact info here. So I'm the only Joe at H2O, so it's joe@h2o.ai. You can also go on Twitter. So I used to have a really evil Twitter handle about MATLAB, but it's like having your ex-girlfriend name on your tattoo on your forehead. But I'm open source now, so don't worry about it. If you want to ask or search question on Stack Overflow, please use the tag H2O. So it's not H20, it's H2O. So some people just get wrong about the H20 thing. So please use H2O. So thank you.
So I'll be talking about Sparkling Water, which is integration of H2O and Spark. The talk was named Sparkling Water 2.0. We created a new version 2.1, so I want to speak about latest versions, so that's why it's a little bit changed. Some boring stuff. Who am I? I finished masters at universities in this town, Charles University in Prague. I like tea, I like mountains, and I'm a core engineer at Sparkling Water team. Who we are, it's Sparkling Water. It's actually a pretty tiny team. We are 3 guys. It's Michal Hava, he's from Czech as well, but he lives in Mountain View, California right now. It's me, I'm still so far in Prague, and Mateusz, he's from Poland, but he lives in Tokyo. So we are a fully distributed team across 3 different continents. But the fact is that it really works for us. It couldn't be actually better, because everything what we do, everything what we share is shared on GitHub. It's open source project. So there is like not any hidden kind of communication. Everything what you need to do, you need to share, which is perfect. You don't come to the office and you don't hear, hey, you guys decided about this thing and I don't know anything about it. So that doesn't happen. So why the Sparkling Water, H2O and Spark? So the first obvious name we could do was Sparkling Water. Oh, I can use this thing. So what it actually does, we don't want to compete with Spark, or we don't want to replace Spark with H2O. Spark is already there for a long time. It has a huge community, lots of existing customers using it in production. And we thought it would be cool to bring some cool machine learning library into Spark. Because Spark has MLlib, which we think we might do better, and we want to give Spark users the availability, the possibility to use H2O machine learning inside Spark. But also Spark gives us also some features we want as well. For example, oh, it's on the next slide. So basically, we try to integrate these 2 tools, get the best out of each tool, and make it work seamlessly together. So what Spark can give us, for example, additional algorithms like natural language processing algorithms. It has, for example, subvector machines, like simple algorithms which we don't have so far at H2O. It has also powerful data merging features like joins, group bys, lots of kind of features, data cleansing you can find in Spark, and it has really cool machine learning pipelines which you want to integrate with. It means that you can export your machine learning steps, data cleansing, and model training into one pipeline, and you can serialize it on disk. You can send it to your colleague. You can send also the model that you train to your colleague. So it's a really nice feature of Spark. But on the H2O side, we have the advanced algorithms like JVM deep learning. You already showed that. Joe showed that to us. You can configure advanced parameters. So it works decently when you don't set anything, but if you really want to tune the behavior up, you can configure it and you can go to expert configurations. It's fully distributed and parallelized. Important thing to note that compared to Spark, we are fully in-memory computation machine platform. Spark can offload some data to disk. We don't do that. We need, if you have, for example, 1 terabyte of data, you need to have a little bit about 1 terabyte of memory. I have a plugin for that, but I just forgot to start it. And as in case on H2O, we have also R Python interface in Spark Importer. You can also use Spark Importer through the H2O user interface. So how Spark Importer can be used? I didn't ask how many people use Spark or have heard about Spark. Oh, cool, that's good. So how Spark Importer can be used? It's actually just Spark package. So what you can do if like Spark is like general computation platform which takes care of like parallelization of your task and data distribution. And what we just need to do is pass Maven coordinates to the -- packages option, and it will download everything to your like local node, and Spark will automatically distribute these classes across all the executors, and it will take care of it. So you don't need to download anything, you can just pass the Maven coordination here, and it will download it. Oh yeah? Okay, so the question was, if I understand correctly, if Spark somehow handles, like, if you have like more performant machines, if it can like distribute the workload there, things like that. Yeah, so Spark can do that if you enable dynamic allocation and yarn preemption. It's like two different things. If you can disable Spark dynamic allocation, it means that Spark will launch new executors on the fly, and if your job decides at some point in the life cycle that it needs, for example, 2 more executors with 100 gigabytes of memory, it will just start it. So the dynamic allocation and yarn preemption is that if you run Spark on yarn, in yarn containers, that the jobs can compete. So if you have like job with higher priority, you pay more dollars for it. The job less paid will get killed, and you need to restart it when you have like free resources. So there are actually cool. So there are actually 3 use cases how people usually use Spark Importer. This one is the simplest one, and it goes like that. People usually have some data source, and they do data using Spark. There is, for example, method Spark as text file. You can load data from CSV files, from Parquet files, from Avro data storage. So there's like various data kind of storages you can use and load data using Spark. Then at some point, you decide that you want to use H2O for machine learning. You just, for some reason, you didn't want to use MLlib. So you need to convert the data format from Spark to H2O. I'll wait for a bit. You need to convert the data format from Spark internal data format to H2O data format. We are a little bit more, the data format is a bit different. We are more compressed than Spark, and it just fits our computation a bit better than Spark format, and you can do like any kind of machine learning modeling here, and then you can again switch to Spark and do predictions in Spark world, or you can continue doing predictions and scoring in H2O. The other use case is, no, this is the last one. The other use case is that you can seamlessly switch between the Spark frames and H2O frames. So you can load data using H2O. For example, H2O import method will load the data from cluster relative path, and you can just start working on it in H2O cluster. And you can then you can seamlessly switch between H2O and Spark and do, for example, Spark can do like you can do like feature engineering stuff in Spark which we don't have in H2O and otherwise. For example, in H2O we have a support for high chirality joins, which means that we can join relay data with high chiralities in pretty small amount of time. Just from our benchmarks, you have to trust me with that, but you can also go to GitHub and see it yourself. We can join 10 billions of rows with 10 billions of rows within 10 minutes, which is kind of impressive result, but it's kind of hard to explain everything here. So if you want to see results and like description how we do that, it's on GitHub. And then you can do modeling in H2O and Spark as well. And the last one, the most popular one is the like offline processing pipeline. So we have some data which we want to train model on. So we again use Spark to like data mining, feature engineering, and we create a model. There is several ways how model can be exported in H2O. You can export it just as binary model, which is just good for storing the model somewhere in database, or that's it. You can also store the model as a POJO, or Mojo. I'll get to that later, but in short, it means that you export the model with all the configuration, and it can live like without H2O anymore. And you can embed it into your own application. That means that you don't need H2O framework running for this, and you can embed it everywhere you want without need to set up H2O cluster. And then you have, for example, some online streaming pipeline. You have data coming from your website. For example, user click on some button and you want to like do some scoring. So the data comes from here. You can do some pre-processing in Spark pipeline or Spark streaming and ship it to H2O and do scoring. You don't ship it actually to H2O. This is like your embedded application, which is using the exported model. It doesn't have to be H2O at all. So just to get you a bit more familiar with Pojos and Mojos, it just takes a bit more time. Well, so to get us more familiar with Pojos and Mojos, those are H2O concepts. We are using them in Spark and Motor. Pojo means plain old Java object, and we just export the object, the model, as a Java class. That's it. It's just one simple Java class which contains all hard-coded configuration which you pass to it, and then you can embed this Java class into your application, and you can use like our simple predictors APIs, which is like available wrappers for these Java classes, and you can do predictions. But you don't need to have H2 running for this. And there is also Mojo, which is like model object optimized. It's another iteration of Pojo. It's not Java code anymore. It's like tree structure hierarchy, and it works a bit better for tree structures, and the performance is also a bit better. And also no runtime dependency on H2O framework, which is good if you want to use this in your pipeline and you don't want to use H2O, you don't want to set up H2O clusters. So to get a bit more to Spark and Motor, I will now talk about features which we have in Spark and Motor, like features we like, and then I'll switch to a bit more technical part of the talk, and I'll explain how Spark and Motor is built technically. So what we have in Spark and Motor, you already see H2O flow, our user interface, and you saw like some Scala cells, like regular cells. Well, you can type like H2O commands, and you can get cluster status. You can get the frames. You can convert the frames. You can train the models. What we can do in Spark and Motor is we also introduce new kind of cell which is called Scala cell, and you can type Scala code in here. It's like Zeppelin notebook. It's not competition. We just wanted to be like consistent. If user can type H2 commands there, we wanted to be able to allow them to write Scala commands there as well. So you can just type Scala there. It will pass the Scala to Scala backend on Spark. It will be compiled there, computed, and the results will be shipped back to your user interface. We also do in Spark, you can load data from different data sources like Parquet file, Avro file, CSV files, using few simple calls, for example, SQL context, read, and data location. And you can use H2 frames as data location as well, using this simple API. And we are using the Spark Query Optimizer as well. So that means that if you are loading the data and you are asking, for example, for just one column, we don't load all the columns. We just load the one column you are asking for. I'll show it at the end because I have more sophisticated demo. And if he can survive this talk, we can see if we are interested in this. And the machine learning pipelines, as I already said, Spark has pretty cool machine learning pipelines. That means that you can export the feature engineering and data cleansing steps along with data training, and you can export it as serialized model, and you can use it later, which is kind of cool feature. We can export the models, but we can't export the whole pipeline at the moment at H2O. So what we want to do is like to reuse existing Spark infrastructure and be able to do that with H2O models. So we are using the concepts which are introduced by Spark. They are called transformers and estimators. You can read more about that in Spark documentation. It's pretty well explained. And the API is unified with this as transformers and estimators pipelines. So if Spark users are used to call some method with some like set something, get something, we do the same. So we don't try to like invent new wheel here. We just follow the same rules as for like Spark people are used to do. That makes usage of this thing easier to Spark people. And I'll show them of the pipeline later. We can also use Spark models in H2O Flow and Spark Motor. What that means is that we don't have every model in H2O. For example, support vector machines are missing in H2O. For example, support vector machines are missing, and we want to be able to inspect them in H2O Flow to get AUC curves in a H2O sense of meaning in H2O Flow. So we created some wrappers around these Spark models, and we can use them as H2O algorithms, as H2O models. And the cool thing is that we can also use them and export POJOs and MOJOs out of them, and that means that you don't need Spark runtime and H2O runtime in order to be able to score using these models. This is just some boring stuff how it's technically created, so let me skip that. Spark model is not just Scala. We support Python and R as well. In Python we call it PySparkling. It just follows the naming convention as PySpark. So if you want to use PySparkling, you just need to go to PyPy and do pip install h2 PySparkling, and it will just get everything, including the jars. It contains every dependency, and you can start using it. We also created, we fixed some issues which were a few weeks later we were depending on specific Python libraries. So with this fix, SV341, it's fixed. So you can use this with Python this PySparkling is Python independent. So you can use it with any Python version you want, and you can switch between them as much as you can. We have also RSparkling, which is integration with R. It's using Sparkly R package by, I forgot who created it. No, just Sparkly R package is pretty cool package which integrates Spark and R word. And we are based on that, and we can use Sparkling Motor and everything what we do in Sparkling Motor using R language. So if you prefer R, you can go with this. It's pretty cool that in this case, it doesn't depend on particular Sparkling Motor version and a Spark version. So it's really separated. So you can use this R Sparkling version with any Sparkling Motor version without need of re-downloading this R Sparkling. And we've also other features in this Sparkling Motor 2.0. In short, support for datasets in Spark. Starting from Spark 1.6, there were introduced datasets, which is good combination of RDDs and data frames. It's I'll skip that. If you need more information about it, just talk to me after that. We have Zeppelin notebook, so you can use this all in Zeppelin interactively. We have XGBoost support. XGBoost support. So far, it's still on local mode. So if you start Spark in local mode, it will be there, and you can use XGBoost. The distributed XGBoost is still work in progress. It's PR waiting for reviews in H2 repo. Hopefully, it will be merged soon, and then we can integrate it into Sparkling Motor. And after that, you can use XGBoost in distributed mode in Sparkling Motor. We have the support for high quality fast joins, secure communication. So, for example, few of our customers they couldn't use this without proper security. So all the security configuration is there and available, and it's already in production at some customers. So it's well tested, and lots of bug fixes. Some coming features in Sparkling Motor 2.0 is to have support for more Spark algorithms in Flow. It's not super critical, but it's just nice to have really integrated APIs and integrated environment. We would like to have Python still in H2O Flow, so even Python people can use the H2O Flow capabilities. It's something like Zeppelin, but more H2O targeted. We also, I did it again. No. We also working on integration with Steam, which is our another product. It's also open source. It's and it's used for deploying the models, and it's like cluster manager in enterprise environment. So it takes care of your cluster starting, closing, model distribution, and you don't need to care about anything. For example, if you have several yarn environments, several hardware configurations, you don't need to care about that, about different configurations. You just say, I want to H2O cluster there, and I want to train this model, and it will do everything for you. Just starting the cluster, you still need to train the models, you need to define the training, but the cluster will be started for you. We want to create more advanced pipelines with mojos. I will do demo with these pipelines, and we will see that it's not perfect at the moment, that it needs lots of improvement, so I can tell you what can be improved in the next releases. and we want to support sparse data conversions. That means in H2O we already support sparse data. That just means that you have vectors with lots of zeros, and you can decode it into like to sparse vector, which just contains positions of non-zero values, and therefore you save the space and save the computation time. And H2O already support that, Spark already support that, and we just need to support this conversion between Spark and H2O in this sparse way. Yes. Like the implementation in H2O terms, implementation is the same. It's just about the backend. So maybe some algorithms can take advantage of the sparse data, but I don't see that much of it. So as far as I know, like the implementation of the algorithms remains the same, and like the backend data storage handles it. But I would leave that to like guys who are implementing these algorithms. Cool. So that's it. And what's inside? So this will be like 10 minutes, a bit more technical, how Spark Motor is created. So just bear with me. I'll try to do it as less painful as possible. So we have 2 backends. The first one, the internal one, was there from beginning, and the external one was created like 1 year ago, and it works pretty well already. And each of those backends, they are good for different solutions, different use cases. Yeah. So I will talk first about the internal backend. This is the easy one to understand, easy one to try, easy one to start with. So in this case, we have a Spark application. We can ship it like application using jar file. So we have application with our main class. It contains the pipeline. It contains like, I will need load data from there. I need to train the data. So all of this code is inside of this jar file, and I give it to Spark. Spark registers this jar file in the Spark driver machine. It's just machine which orchestrates the communication in the cluster, and it will send the jar file to each executor. Spark executor JVM. They are usually located on different nodes in the same network, or it can be in a different network. And inside of this, each Spark executor, we start H2O. So it's kind of hacky solution. We are starting cluster inside cluster. So each Spark executor has one H2O node, and we start Spark cluster of size 3, and also H2O cluster of size 3, and it's living inside of Spark executor. The advantage of this is that we don't need to configure anything. Everything works out of box with some caveats which I will cover in a bit. Good thing about this is that we also have one memory space because we live in the same JVM. Oh, sorry, I should configure that. So you live in the same JVM space, so you can access the data produced by Spark by H2O directly without like deduplication of the data, which is good in this case. So this is just different picture. You can look at the same thing. We have a Spark context, which is like main class, which is used to start your computation and jobs on Spark. It communicates with each Spark executor, and on that we created like wrapper called H2O context, and it does the same thing, exactly the same thing as Spark context with H2O nodes. So it just communicates with H2O nodes inside Spark executors, and it orchestrates the work. The data transfers are easy in this case because we don't need to do any data duplication from data frame to H2O frame. We need to, well, slightly. In this case, we need to compress the data, and we need to compress just the data we need for the future work. In the other case, we don't do any data duplication. We just create small wrapper around this H2O frame. And we create data frame wrapper, and when the user asks for it, we don't do the computation right away, and we behave lazy, because Spark, it doesn't start computation right away. It creates a direct acyclic graph, and it just starts the computation when you run some action, for example, count, collect, and actions like that. So at that point, it will start the computation. So the pros and cons of this solution is that it's easy to configure. You don't need to spend almost any time on it. It's faster because you don't need to send data over network. It's living in the same JVM, so you can access data right away. Disadvantages, and this is just because of the technical reasons inside of Spark, we are not able to handle the cases where Spark joins and kills already existing executor, because there is no API which give us this information, and you can't tell in advance how many executors will there be in Spark world. So this is just not possible to discover, and in order to be able to work correctly in this case, we need to have H2O in each side of each of Spark executor. So that can be tricky. It can be configured. We have tuning guide where you can configure some Spark options and make this behavior as low as possible. It works for most of the people, and for most of the customer the solution is perfect, and it works for them. But if you move to bigger data, like terabytes, let's say thousands of executors, it can be kind of tricky to use this solution. So in that case, the new external backend was created, which is able to handle really big data and a lot of executors, and by lots I mean thousands. Normally when you try it locally, you try 2, 3, 10, 20, 100 executors, it's still fine, it's like nothing. But if you want to run 5,000, 10,000 Spark executors, you don't start each executor at the beginning. It will be just waste of resources. You start 1,000, and the other guys are just started when they are needed, and it's not possible in the first solution. So the external backend works in a way that we start H2O in external. We start H2O cluster externally. So normally, as people, you just do Java jar, H2O jar. You start H2O cluster manually, or it can be done automatically by the API of this thingy, and you connect to it. And from that point on, the communication and the APIs of the Spark motor is the same. It's just the thing that you have the two separated clusters, Spark cluster and H2O cluster, and you communicate with external separated cluster. The advantage of this is that we are no longer affected by Spark executors joining and being killed, because we have just small stop running in each of Spark executor, which can come and go. We don't care. If it's killed, we don't care. We just start it again. It's no problem. And the H2O cluster, which is running externally, is not affected by this behavior. So I already covered that. It's like separation approach. You start the H2O context in the same way as before. You just pass it, for example, IP address and port of already existing H2O cluster, and it will connect to it. In YARN mode, we can start a cluster automatically for you. So it's, for example, good for UsiFi jobs, and automatic deployment of pipelines, and also better resource managing. So how it looks on the picture, again the same stuff. We have application jar, Spark driver machines, Spark executor machines, and instead of having H2O inside of each Spark executor machine, we have H2O externally, and we have small stubs which communicate with H2O in external mode. We can even have more H2O nodes than we have Spark executors. It's really separated. Again, the same picture. We no longer run in Spark executors. We have separated cluster. So pros and cons. We don't crash when Spark executor goes down or when a new executor is joined. We can tune we can have a better resource managing, because we have like two clusters. We can configure Spark and H2O differently. For example, for H2O it's good to disable YARN preemption, because when you just kill one out of H2O cluster, the whole cluster will go down. It's not like something what we just couldn't handle, but it's usual. That's just usual what people do in machine learning world. They don't support H2O if they want to be really high performance. It can be definitely done. There are some futuristic plans that we might be able to handle these cases and support high availability, but it's just not on the radar. So if one H2O node goes down, the whole H2O cluster goes down. Disadvantages are that you need to transfer the data between these two clusters. So there is overhead of transferring the data. We do like a lot of compressions before we send the data, but you still need to send it. So far there are no benchmarks. We are working on that with one customer. It works well, pretty well, but benchmarks are not public yet. It just has 2 modes, I already said that, so you can start H2O cluster manually. That means that you are responsible for starting the cluster and then you can connect to it. You can also use the automatic start mode, which will start the H2O cluster on provided yarn queue for you, so you don't need to care about this deployment. And usually when people start thinking seriously about this deployment of this, they should use yarn or something like that. They should use like standalone modes. And now I will just show one quick demo. I won't show the other ones like SVM1 and what was the second one? The data source API. So this will be just the pipeline demo, and then we are done. Oh, can you see that? No. I won't be spending much time into this. I've just typed 2 commands to start, and I will use Flow user interface. So I just want to start sparkling water. I'll just use Spark shell command, which is provided by Spark environment. I will start 3 executor nodes. Each will have 3 gigabytes of memory, and the driver node will have 3 gigabytes of memory as well. So my cluster will have 12 gigabytes of memory, which is for my reasons well. And I'll just give it a sparkling water jar. That's it, I can start it. This will take like 15 seconds to start because Spark needs to initialize itself. Also, so we have a Spark session available. We can go to Spark UI, and we can like see what Spark is doing. So far, nothing interesting. We have 3 executors. No executor is dead so far, and we have 4 nodes. And I want to start sparkling motor, so I just need to do some specific imports, and I need to start H2O context, which is like wrapper around Spark context, and I'm passing the Spark context to it as part of the method. And from that point on, I won't be coding anymore. I'll be showing that in our user interface. So right now, we are starting H2O on each Spark executor, if it's possible. In these cases, in cases of like 3 nodes, it's no problem. So I can see that we have 3 executors, and we can start H2O. We have a H2O running in them. So right now, I will open our user interface. So load. It just takes a bit more. Okay. And let me make this bigger as well. Good. I can go, like this is the user interface Joe was showing. You can do anything you want here. You can, for example, you can see cluster status. I have 3 nodes. They are running inside of Spark executors. Total memory is 10 gigabytes. Some performance metrics, garbage collection information. So all interesting things you can get here. Let me go to the flow I want to show. It's called Hammer Spam Pipeline. And what this demo is about, it will demonstrate how deep learning can be used to predict whether the given message is spam or ham. So I just give it I have a really tiny data set where I have messages and I have labels which say whether the message is spam or ham, like if it's correct message or spam message. And I just want to create a model which will do these predictions. And we can see that it really won't be much of coding. I'll be just executing these steps. So right now, I'm using the flow commands. This is still no any Scala, and it will help me to do these steps. So I can import the files. If I click on it, it will just guide me. I can put their files locally. I can put files from S3, from GitHub. It supports HDFS, lots of data storages. So I just want to import the data. I'm importing the data from GitHub, the SMS data. It's really just 2 columns, message and label. It has few kilobytes, but just wait for it. still waiting. Maybe if you have any questions, this is a good time. The internet here is not that fast. Okay, so let's wait. Yeah. I probably don't understand if you can repeat it, maybe.
Okay, so you use internal backend and backend, there are like two opposites, so there are like some approaches or ideas how to try something mixed.
I would say it would make much sense to create it, because they are really opposite ones. And like any mixture of these two would expose at least one of the problems on each of the sides. So we either have like full high availability and either like the full speed. I would say if you like start mixing those, you would still be affected. If you would just start portion of executors, separate portion of H2O nodes, oh, it's still running. If you just start portion of H2O nodes separately and portion of nodes inside of executors, you would still be affected by like Spark killing those executors. Maybe let me go further and I will just execute it afterwards, or I can just connect to my hotspot here, but I'll do that later. So let's just trust me. This imports the data. I can parse the data afterwards. So again, I just do setup parse, and the flow will help me with that, and it will tell me like what I need to fill. So I'm just parsing the data in here. Maybe let me just try to rerun it one more time. Okay, so I guess no results. So I'm gonna parse the data. I don't need to write this if I just type new cell, insert new cell, insert new cell. Yeah, I just skip it for now. The demo will be the same. Just trust me with this. So this is the parsing, and I created the data as Spark data, and right now I want to switch to H2O frames because I want to do H2O modeling. So I can use the API method which is called as data frame, and I can convert the data. This is converting the data to Spark frame because I loaded the data as H2O frames, and I want to use Spark feature engineering methods. So I'm just switching the data from Spark to H2O right now. From H2O to Spark. Here I need to do some important imports, just what you need to do to run the job. In the next step, I'm already using the Scala cells here, the black ones, so I'm typing Scala code here, and then when I execute it, it just goes to backend, it's executed there, and it goes back with the results. I'm just starting myself SQL context and H2O context, so I can make use of these H2O modeling techniques. And now I can start defining the pipeline stages which will be used to run the predictions and feature engineering steps. The first pipeline is defined by Spark. We have done nothing in this. It's called regex tokenizer, and you just give it Spark data frame which has input which has some column named text. It will create new column named words, and it will just remove all the columns which doesn't have this pattern, which contains numbers, some big characters, or the words which are lower than 3 characters, smaller than 3 characters. So we just don't need them. In the next pipeline stage, I use stop words remover. It just says I'm not interested in some words. So take the output column of the previous stage. You can see it here, tokenizer output column. Create new filtered and just remove some words. We are not interested in prepositions and articles, so just remove them. The next stage is that in order to be able to do some predictions on it, we need to convert the strings to some numbers. In H2O, you don't need to do these steps. H2O can handle like string automatically, but in terms of Spark, you need to first convert Spark to some numbers. So I just convert the strings to some hashing space, and I use indexes of these strings later. The next stage is to create inverse document frequencies model, TF-IDF, which just tells me how important the word is in a given corpus. So let's say I have a SMS data text file and I have lots of words there, and I just want to see how, for example, word television is important in that corpus. So I create the model, and these were so far just Spark transformers. These are new ones and are H2O transformers, but they have the same API as in terms of Spark. It will be improved a bit later in the next iteration of pipelines, but so far we need to work with that. And we need to we want to split the data into two parts, like training part and validation part. So on the training part, we will train the model, train the algorithm, and on validation, we just validate it. So that's what this step does. The next stage is, this is column remover. Sorry. This will just remove unnecessary columns. Pretty easy. The next one is the splitter, which splits the data into training frame and validation frames. So you can see I'm setting the keys here for the output frames. I'm setting the ratio, so I will take 80% for training data and 20% for validation data. And in the next stage, I can start H2O deep learning. Really, the API is the same. I configure it using the very similar API to Spark. So far, no execution is done, so it behaves lazy. I just defining the stage. No execution is done at the moment. And at this stage, I create a pipeline. Right now, we can't use the Spark pipelines. We have to create special H2O pipeline, which is limitation at the moment because people have to rewrite the code and use our H2O pipelines instead of regular Spark pipelines. I have already a PR in the Spark Motor repo for that, so we'll fix that, I hope in 2-3 days. But right now I define all the stages and I create pipeline. And now it's starting to be interesting. I will load the data from the data frame I created at the beginning of the code, and I call pipeline fit on the data. And what this does, it will go through each of the stage. So it will remove the unnecessary words, it will hash the words, it will create a deep learning model out of these words, and it will create model. But model which just doesn't do the scoring, but it goes through all the pipeline if you pass new data to it. This is just showing that we can export the model on disk, the training model. We can also export the pipeline, which can be fit to new data later, and you can again load it. So we can, for example, store it into database. What we want to do in H2O in the next iteration is to have the POJOs and MOJOs, which I mentioned earlier, for this thing. So you can export Java code containing whole pipeline. Because right now, Spark just give us availability to export as serialized model. And here I'm creating like simple predictor function where I just pass a message to it. I pass it a model, H2O context, and a threshold, which just decides whether the message is spam or ham. I just wrap this small text as a Spark data frame, and I execute a model on it by calling model transform. And it will go again through each of these stages, and it will return the score, the predictions. And when I run this, if I would be able to run that, if I would have the data, sorry, I should have downloaded the data before locally. And then if I would run the first thing, it would return false because this just means like some nice message. We would like to have wine after the meetup. But the second one seems like some stupid advert, and it would return that this is a spam. So sorry that I wasn't properly prepared. I can run it locally if you are interested in that, and if you don't trust me after the meetup. Let me just go back to the slides and let me wrap this up. So that was demo time. If you would like to have more information about Spark and H2O, we have lots of resources. You can go to H2O AI blog. You can go to YouTube, where we have recordings of various conferences, like Spark Summit in San Francisco, H2O Worlds in Dallas, Chicago. So lots of materials there. You can also go to GitHub. It's all open source. You can contribute. We love contributions. Yep. And thank you. I know it's already cliche, but I have to say it. We are hiring, so if you would like to work for H2O, sparkling water, interesting GPU stuff, please talk to me, but we all have interesting jobs. So that's it from me. Thank you.